Welcome to today's paper reading. Today's paper is titled, On the Diagram of Thought. This paper introduces the Diagram of Thought framework by Yifan, Zhang and colleagues from IIS, Tsinghua University, and Shanghai Artificial Intelligence Laboratory. The work is currently under review. The Diagram of Thought framework introduces a novel approach to modeling iterative reasoning within large language models, LLMs. Unlike conventional methods that depict reasoning as linear chains or trees, DOT structures reasoning as a directed acyclic graph, DG, within a single model. This DG organizes propositions, critiques, refinements, and verifications into a cohesive structure, enabling the model to explore complex reasoning pathways while ensuring logical consistency. Each node in the DG corresponds to a proposition that has been proposed, critiqued, refined, or verified, allowing the LLM to iteratively enhance its reasoning through natural language feedback. By leveraging auto-regressive next token prediction with role-specific tokens, DOT facilitates seamless transitions between proposing ideas and critically evaluating them, providing richer feedback than binary signals. Additionally, the DOT framework is formalized using topos theory, which provides a mathematical foundation that guarantees logical consistency and soundness in the reasoning process. This approach not only enhances both the training and inference processes within a single LLM, but also eliminates the need for multiple models or external control mechanisms. DOT offers a conceptual framework for designing next-generation reasoning specialized models, emphasizing training efficiency, robust reasoning capabilities, and theoretical grounding. The capabilities of large language models, LLMs, have expanded significantly, yet their proficiency in complex reasoning tasks remains limited. Traditional approaches like chain of thought, COT, represent reasoning as linear sequences of intermediate steps, which may not capture the complexities of human reasoning. In this paper, the authors introduce the Diagram of Thought framework, which models logical deduction as the construction of a directed acyclic graph, DG, within a single LLM. DOT incorporates natural language critiques, allowing the model to receive detailed explanations of errors, facilitating deeper understanding and more effective refinement of propositions. By embedding the entire reasoning process within one model and leveraging auto-regressive next token prediction with special tokens, DOT eliminates the need for multi-LLM collaboration or external control mechanisms, simplifying deployment and aligning closely with standard training paradigms for LLMs. Figure 1 illustrates the Diagram of Thought framework, which models logical reasoning as the construction of a directed acyclic graph, DG, within a single large language model, LLM. The DG consists of nodes representing propositions, critiques, refinements, and verifications, with edges denoting logical relationships or dependencies between them. This structure allows the model to explore complex reasoning pathways while maintaining logical consistency. Each node corresponds to a proposition that has been proposed, critiqued, refined, or verified, enabling the LLM to iteratively improve its reasoning through natural language feedback. Figure 2 illustrates the process of asking a large language model, LLM, to compare two decimal numbers, specifically 9.11 and 9.8. The LLM's task is to determine which of these two numbers is larger. This example highlights the model's capability to perform basic numerical comparisons, showcasing its potential in handling quantitative tasks. Figure 3 illustrates the interaction with a large language model, LLM, where the user asks the question, "How many R's in the word strawberry?" The LLM responds with the answer 3. This example highlights the model's ability to process and answer specific queries about word composition. In the realm of reasoning frameworks, several approaches have been developed to enhance the capabilities of large language models, LLMs. The chain of thought, COT, approach, introduced by Wei et al. In 2022, enables LLMs to generate intermediate reasoning steps, making the latent reasoning process explicit and improving performance on complex tasks. However, COT's linear nature may not fully capture the nonlinear aspects of human reasoning. To address this, Tree of Thought, taught by Yao et al. In 2023 extends COT by allowing multiple reasoning paths, accommodating branching and backtracking. While flexible, these approaches can be computationally intensive. diagram of thought distinguishes itself by integrating these strengths into a unified framework within a single LLM, modeling reasoning as a directed acyclic graph, DG, to capture nonlinear and iterative reasoning while maintaining computational efficiency. The diagram of thought framework models logical reasoning as a directed acyclic graph, DAG. In this framework, nodes represent propositions, critiques, and refinements, while edges denote logical relationships. The acyclic nature ensures the reasoning process avoids circular dependencies. Within the DOT framework, the LLM manages three roles. The proposer generates propositions, the critic evaluates them, and the summarizer synthesizes the reasoning. The reasoning process begins with the proposer introducing a proposition, followed by the critic's evaluation. Based on the critique, the proposer refines the proposition. This cycle repeats until the propositions are verified, after which the summarizer synthesizes the reasoning into a coherent chain of thought. The DOT framework is formalized using Topos theory, which provides a unifying framework for mathematics and logic. In this context, a topos is a category that supports internal logic, where propositions are modeled as subobjects of the terminal object, and inferences are represented by morphisms. The iterative reasoning process is captured using columnates and prenet categories, which aggregate all reasoning steps into a coherent object. This approach ensures logical consistency and soundness by preventing circular dependencies and ensuring all valid inferences are included. The formalization also highlights the role of category theory in informing the design of reasoning mechanisms in LLMs. In this paper, the authors introduced the diagram of thought framework, which models iterative reasoning in large language models as the construction of a directed acyclic graph within a single LLM. This framework integrates propositions, critiques, refinements, and verifications into a unified DG structure, capturing the complexities of logical deduction beyond linear or tree-based models. The authors also provided a topos theoretic formalization of the DOT framework, offering a mathematical foundation that clarifies the relationship between reasoning processes and categorical logic. This theoretical grounding ensures logical consistency and soundness in the reasoning process, validating the efficacy of DOT and enhancing the reasoning capabilities of large language models. The framework leverages auto-regressive next token prediction with role-specific tokens to manage role transitions seamlessly, enabling the model to generate detailed reasoning processes without external intervention. Thank you for watching.